Hello everyone, I am Chidrala Ashwini. Today in this video we are going to discuss about our Capstone project. Our Capstone project title is Enhancing Student Engagement in Engineering Courses Through Personalized Book Recommendation System. We are doing this project under the guidance of Miss Faiza Madam. So we are a team of 5. Before going into our project video, let me introduce my teammates.
Everyone, this is Shashanka Basani.
Hello everyone, my name is Pranavi.
Hello everyone, I am Madhusri.
Hello everyone, I'm Sai Priya Takkars.
Our project title is Enhancing Student Engagement in Engineering Courses Through Personalized Book Recommendation. We are batch of coming to the abstract. The system provides tailored reading recommendations for academic purpose. Our project named Enhancing Student Engagement in Engineering Courses Through Personalized Book Recommendations covers a wide range of book genres, and it is intended to benefit students in a number of academic subjects such as computer science, electronics, artificial intelligence. It makes use of two main approaches: content based filtering, which purposes books based on a student search history and preferences, and another method is collaborative filtering, which makes book recommendations based on the taste of students by combining various methods. Introduction. A book recommendation system is a type of software designed to suggest books to users based on their preferences, behaviors, and other contextual data. The systems are widely used in online bookstores, libraries, and educational platforms to help users discover relevant books and reduce the time spent searching for resources. They aim to enhance user experience by providing personalized suggestions that match each user's interest, past interactions, and sometimes even their unique goals. Enhancing student engagement in engineering courses through personalized book recommendations aim to improve learning experience from engineering students by leveraging personalized content delivery. In today's interdisciplinary academic environment, students from diverse fields such as computer science, electronics, and artificial intelligence require tailored resources that align with their academic and personal interest. Domain knowledge.
So our project domain knowledge is to develop this book recommendation system for engineering students. Key domain knowledge includes book engineering books, familiarity with engineering disciplines, common textbooks, academic levels and interdisciplinary topics, machine learning, understanding the recommendation algorithms, collaborative and content-based hybrid and evaluation, metrics like precision and recall, and natural language processing skills in text processing, topic modeling, and keyword extraction to analyze book content and metadata. So, recommendation system techniques, knowledge of collaborative and content based filtering, hybrid approaches, and solution for cold start and and data sparsity problems. And next, motivation. Our motivation for undertaking this project came from our own experiences. As engineering students, we often struggle to find the right books to study. With so many options, it can be confusing and difficult to decide what to read. We want to create a recommendation system that helps other students, especially our juniors, find books that match their interests and learning needs. This system will save time, reduce confusion, and keep students motivated by showing them best resources for their studies, whether they are in computer science, electronics, or any other engineering field.
Problem statement. Students often struggle to find the right books for their courses and academic needs. With so many resources available, students can feel confused and waste time trying to choose the best book to read. There is also a challenge for new students who don't have much reading history, which makes it harder to recommend books to them. Most book recommendation systems are too general and don't consider to the specific needs of a students in these specialized fields. Next, objectives. Developing a personalized recommendation system. Creating a system that provides book suggestions tailored to students' courses, interest, and branches. Address cold start problem. Implement strategies to recommend books to new students by their branch. enhancing book discovery, improving the process of finding high quality course specific books, reducing time spent searching for resources by rating of the books, improving user experience, building a user friendly interface for students to easily access and navigate their book recommendations.
Existing system and disadvantage of existing methodology. Existing book recommendation system often give general suggestions that don't really fit the needs of engineering students. These streams usually use one of the two methods: content based filtering, which recommends books based on similar titles, or collaborative filtering, which suggests books like users with similar tastes. However, they don't personalize recommendations for specific courses and often overlook the latest resources available. Our proposed method improves the recommendation process that their branches and using the books that students have previously searched for, creating more personalized experience. Our system combines both combined content based and collaborative filtering techniques to suggest relevant textbooks and latest resources specifically for different engineering courses. Our system also suggests new available books to explore and learn. Gaps identified: lack of personalized recommendations for engineering students. Current book recommendations do not focus on specific needs of engineering students, particularly across different branches like computer science, mechanical engineering, and electronics, so on. Cold start problem for new students. Suggesting books for new students and users is quite difficult. Difficulty in finding relevant books. There is no such efficient system for students to easily discover books that are directly relevant to their specific courses and academic interests, leading to time wastage and confusion. Data scarcity in engineering fields.
And this is our data set. We prepared this data set by collecting book information like type, course, branch rating, published date, and description of every book from college library and internet resources like Google. Here are some attributes of data set. Attributes of data set are book title, course, branch, rating, and published date and book description. Coming to UML diagrams, we designed few UML diagrams for our project. And first one is class diagram. Second diagram is use case diagram. And this diagram is sequence diagram. And this is activity diagram. This is state chart diagram. And at last, this is deployment diagram. Coming to our methodology, these are the steps we followed in our project. First step is data collection. So we collected data from various resources like libraries and internet. Next, data pre-processing. We cleaned and cleansed our data using some data cleansing techniques. Next, we combined used two algorithms, namely content-based filtering and collaborative-based filtering. And the main solution is first recommending books for the new users is a cold start problem. So we developed a solution for this using these two algorithms. At last, deployment, that means recommending books and user interface. Coming to algorithms used, we used content-based filtering and collaborative-based filtering. Content-based filtering is a recommendation strategy that uses item attributes to suggest more items that are comparably to those in which a user has experienced interest. It works by analyzing information such as keywords, genres, subjects within the content to detect similarities and recommend new content. This algorithm also works by cosine similarity, turn frequency, inverse document frequency, and embedding based models. Second model is collaborative based filtering is a recommendation strategy that anticipates the user preferences by aggregating preferences from multiple users. It operates on the assumption that customers who have previously agreed with most likely agree again in the future. Here are results of our project. First, this is a bar plot of distribution of ratings of different books. This is pie chart for distribution of books by branch. In this, we can see CAC with highest with 24.2% of books. Next, this is our results. We plotted results using different matrices like precision, recall, and F1 score. And average of precision is 70%, average of recall is 100%, and average of F1 score is 81%. And these are user interfaces.
Conclusion and future scope are of our project. Conclusion. Our project engineering students book recommendation system demonstrates promising results with an average precision of 0.70, average recall of 1.0, and an average F1 score of 0.81. These matrices indicate that our system effectively retrieves relevant books and performs well in balancing precision and recall. This performance suggests that the recommendation system is particularly strong in identifying relevant books for students. Future scope of our project. Future enhancement for this book recommendation system could include integrating additional data sources such as academic journals, articles, and links to online resources to provide a broader selection of study materials, expanding the dataset with more comprehensive book metadata and student feedback can improve personalization and recommendation accuracy. Additionally, incorporating real-time updates to adapt recommendations based on trending topics or new courses could enhance system relevance and usability. Thank you.